Okay, in this video, we're going to be looking at solving logarithmic equations. So let's have a look at example 4a here, which is log base 5 of x equals to 3. In this particular case here, if we want to free up the x, we need to take this log to the right-hand side using the opposite operation. And the opposite operation of a logarithm is a 5. Now notice here how we said log base 5. Since that is a base of 5, when we move it to the right hand side, it will also retain a base of 5. This 3 here then becomes the index. So in the next line, we can just evaluate. If we go to example B here, you can see that we've got a subtraction of 2 logs. So what we can do here is merge the logs because they have the same base. And since we are subtracting, then what we can do is divide the inside of each log. Now that there is only one log, we can shift this base of 2, log base 2, to the other side. And yes, it retains its base. So on the left hand side now, the log has been released and we end up with a base of 2 to the power of 4. We're going to continue on here. So 2x plus 1. We're going to move this base of the denominator, of x minus 1 to the right hand side. In the meantime, I will also evaluate 2 to the power of 4, which is 16. So we've got 16 times x minus 1. I'll just move this over a bit because we're going to take this up now and we're going to continue it in the next column. So I've got 2x plus 1 equals 2. We're going to expand this here, 16x minus 16. And we're going to take 2x to the right hand side. That becomes 14x. Likewise, we're going to take this minus 16 across. So that's 1 plus 16, which is 17. Last but not least, we've got 17 over 14 equals to x. We can leave it like that. Example number 3 here, or part C. You can see that we've got log base 3 for all of them. Okay, it's pretty convenient on both sides of the equal sign. So on the left hand side, what I'll do is I will merge the brackets, and since we're adding logs, we will multiply whatever's inside the bracket. Now the interesting thing here about logarithms is that if you have a log on either side and they're encapsulating a bracket, they will both cancel out. So what we will have here is just whatever's left inside the bracket. I'm going to expand the bracket here. This turns into a quadratic expression, so we're going to take 4 across, and we're going to continue here until we solve this quadratic. There might be a caveat, so once we get there, we will have a discussion about that. So we can see here we've got minus 4 and x plus 1. Therefore, using the null factor law, we'll have x equals -1 or positive 4. Now, just looking back up here, if we take our solutions and plug it into either one of these, there is a restriction on this log section here. What we need to take note of is that whatever's inside the bracket must be greater than 0. So therefore this x minus 3 here must be greater than 0. So x has to be greater than 3. But which one takes priority here? X is greater than 0 takes priority. Well, whatever's common, actually. So, in fact, X is greater than 3 takes priority. Let me draw that out on a number line. So let's say our number line is X here. If we have 0 and we have 3, if X is greater than 0, we've got this. But if X is greater than 3, then we have this. Now, if we ask ourselves what's common between both of these lines here, the top line and the bottom line, it's actually this point onwards. Okay, so we're just going to highlight that segment there. That's what's common. So out of these two solutions here, we have to accept a solution that is where X is greater than 3. Therefore, X must equal to 4, since X must be greater than 3. You can take a moment to pause here with this solution. But the tricky part here is taking into consideration of the domain. Once we look into logarithmic graphs, that's when we'll start to recognize the behavior of that. Now, it's your turn to do these questions here. These 3 questions, A, B, and C. I'll take a pause between each one and I will display the solution. Or, if you don't mind, I'll just play along here and you can watch. I won't do a lot of talking. That's a solution for part A. Part B. Difference of perfect squares here, such that when you have A minus split B times A plus B, that becomes A squared minus B squared. You can expand this bracket according to using expansion, brackets of expansions if you would like. Do it on the side and you'll see what it comes out to. Just taking note here that this log base of 3, I've moved it from the left hand side to the right hand side, and that base there of 3 becomes the base on the right hand side. Now, we've got plus minus 2, but remember, let's take into consideration here of our solutions. Do we have a domain that we need to restrict this? Whatever's inside the bracket, let it be greater than 0. So X is greater than 1. X plus 1 is greater than 0. X is greater than negative 1. So the common one between both of these is X is greater than 1. So since X is greater than 1, then our only solution is 2. If you would like, you can draw this out on a number line, similar to our previous question here, and highlight the segment of the graph which shows the common part between these two restrictions. There's a solution for part B, so feel free to pause if you need to. And I'll move on to part C. What I'm going to do here is just take this login take this 2 here and bring it up to the power. And in the meantime, over on the right hand side, since they are adding both logs, I'm going to multiply whatever's inside the bracket. Now, I'm noticing that there's a log base 10 for each of these, and I see that this is just a number 1. The way that I can re-express this 1 here, if I want to introduce a log base of 10, is do log base 10 of 10. Because essentially, 10 to the power of 1, which is this 1 here, is equal to 10. So we can re-express that as log base 10 of 10 is equal to 1. It's the exact same definition. If this part still confuses you, make sure you take the time to pause the video and draw it out to map out, because this 10 here is the base of 10 at the bottom, and this value here of 10 is over here. I'm going to continue on here by expanding this bracket. Now it is perfect squares, so we've got a squared plus 2ab plus b squared. Over on the right hand side here, I'm going to expand the brackets. And since on the left hand side here, now that we have it as log base 10 for both of them, I'm going to merge the brackets on the inside, and by merging, I'm multiplying. So I've got 10x squared plus 20x plus 10. On the right hand side, stays the same. We're just cleaning up these two like terms. Now, because we only have log base 10 on either side, we can essentially cancel them out. We're left with the inside of each bracket. And with 10x squared on either side, they will cancel. If I take this 20x over to the right hand side, we get 21x minus 20x. I'll just write it out. And on the left hand side we have 10. If I bring this 8 across, it will be minus 8. So we've got x equals to 2. That is it. This one was heavily involved with expanding quadratic brackets. There was also a little trick here. There was this merging or multiplication, and then the cancelling of logs on either side. So that's how you solve logarithmic equations and apply them in several different contexts. Thanks for watching, and don't forget to rewind and replay if you need to rewatch.